All right, let's see if I can fit number 11 right here. They're telling you the zeros are -1, so x equals -1, x equals -5, and x equals 1/2. So we're going to turn each of those into factors by putting them in parentheses, and instead of x minus 1, it will be x plus 1. Instead of x equals -5, it'll be x plus 5. And then the 1/2 will be minus 1/2. So we need to multiply these together. We can pick any two to start with, but I'm going to go ahead and pick the first two. So first, let's FOIL those. X times x is x squared. X times 5 is 5x. Next, we have 1 times x is 1x, and 1 times 5 is 5. Let's combine like terms. So the 5x and 1x can go together, and we'll have x squared plus 6x plus 5. Now we need to take that answer in blue and multiply it by the x minus 1/2. Since it's a 3x2, I'm going to make a 3x2 box for this. So on the side, I'll put the x in the minus 1/2, and I'll make it a decimal. And then I'll put the x squared, the 6x, and the 5 on the top. So now we'll go through and fill in the box. X times x squared is x to the third. X times 6x is 6x squared. And x times 5 is 5x. On the bottom, -0.5 times x squared is -0.5x squared. -0.5 times 6, negative half of 6, is -3x. And -0.5 times 5 is -2.5, or 5/2. Last, we just need to combine like terms. It looks like we have x squareds on the diagonal, and also these x's on the diagonal. So the final answer is x to the third. 6 minus 0.5 is 5.5. X to the seconds. 5x take away 3x is plus 2x. And then last, it's the minus 2.5. So that answer in blue is your final answer. Number 12. We need to factor. So we think, do we have a GCF? Nope. These three things cannot all be divided by the same thing. So we try to make two factors and find the factors of 70 that add up to -17. So you know 7 and 10 will give you 17, but since it's -17, they both need to be negative. So x minus 7 and x minus 10. That way when you add them together, it's -17, and when you multiply them, it's positive 70. On number 13, the leading coefficient, right here, is the very first number, so that's -5. The degree is the highest exponent, so the degree is 4. And the end behavior is which way the arrows point. So you're allowed to just draw two arrows. Since the leading coefficient's negative, it means the arrows will point down. Since the degree is even, 4 is an even number, it means they're both going to point the same direction. So, like that. Your other option would be to type that equation into y equals on the calculator and just look at the graph, and you would be able to see which way the graph goes. On number 14, the fundamental theorem of algebra basically tells us that whatever your degree is, that's the number of zeros you'll have, including real ones, imaginary ones, and multiple ones. So the degree of this polynomial is 5. That means it has 5 total zeros. If you graph that on the graphing calculator, it looks, I forget how it looks, but I know that it just crosses the x-axis one time. So it means one of the zeros is real. Since there's 5 total, it means that the other 4 must be imaginary. Number 15. Let's see. This is find the product, which means we need to multiply. Also, there's a little times sign right there. And so we have 2 terms by 3 terms. So I'm going to go ahead and make another 2 by 3 box. And to save space, I'm going to make the top of the box right here and the side right here so that those top terms are already lined up and I don't have to rewrite them. Alright, and that's a positive 2 in the last box. So let's go ahead and start multiplying. 5x times x to the third is 5x to the fourth. 5x times negative 5x is negative 25x squared. And last, 5x times positive 2 is 10x. On the bottom, we'll have negative 3x to the third. Negative 3 times negative 5 is positive 15 with an x. And then last, negative 3 times positive 2 is negative 6. That's a positive behind there, by the way. So let's combine like terms. There aren't any other x to the fourths, so we have 5x to the fourth. There aren't any more x to the thirds, so we just have minus 3x to the third. There aren't any more x to the seconds, so minus 25x to the second. These we can put together. 15 and 10 is 25x, and then the minus 6 goes at the end. So that green part is your final answer. Number 16, it says to graph. So you are going to put that equation into y equals on your calculator. We're looking for a couple things. First, the real zeros. So where does it cross the x-axis? If you look on the calculator, it crosses the x-axis 3 times, and you can confirm it on the table. It crosses at negative 2, negative 1, and 2. So on the graph, you need to have a dot at negative 2, negative 1, and 2. And that's right on the calculator. Next, we need the y-intercept. That's the constant term. So the number with no letter. In this case, the y-intercept is negative 4. If you didn't have a term with no letter, then it would be 0, and your y-intercept would be 0. So we'll put a dot down there at negative 4. Now the local max and the local min. The local max is where it looks like a hill on the graph. The local min is where it looks like a valley. So if you hit the trace button, you can make the little cursor go to the very top of the little hill. And when you do that, at the bottom of the screen for the max, you'll see it's about negative 1.5 for the x, and for the y, it's about 0.9. So that means in between those two zeros, it's up almost 1. For the min, all you need to do is hit the over buttons until the cursor's at the very bottom of the parabola, or not the parabola, but that little valley shape. And you'll see that that happens at about 0.9 for the x and like negative 5.9 or about negative 6 for the y. So we'll plot that almost over to 1 and down to negative 6. Now that we have all that, we just need the end behavior, which you can see on the graph, opposite arrows, and the ending 1 points up. So now we sort of have the outline of the graph, and all you have to do is just draw your graph right through those dots. If I do not see the dots clearly labeled on your test, you will not get full credit for this question. There's spaces where you're going to fill out all of this information, so you'll get points for filling it out, but you also need to actually put the dots on the graph. Last question, we need to factor and then state the multiplicity of each root. So if we have more than one, we'll say so. So always the first step in factoring, look for a GCF. Also, the leading coefficient's negative, so we'll for sure divide by a negative, and it looks like negative 3x to the third is the GCF. So we'll divide each of these by that. I'll write it out front, negative 3x to the third, and write the leftovers next to it. So negative 3 over 3 reduces to just 1x squared, because 5 minus 3 is 2. 6 divided by negative 3 is minus 2, and 4 minus 3 is just x to the first. And then 72 divided by negative 3 is minus 24, and those x to the thirds cancel out. So I'm going to recopy the minus 3x to the third out front, and we're going to try to break this into two factors. There's 3 terms, 1, 2, 3, so we're going to find the factors of 24 that subtract to get negative 2. So the factors of 24, we need to minus them. So it's not that, it's not that. 3 minus 8, that would give us 5. But 4 and 6, if we subtract those, we can get negative 2. 4 minus 6 is negative 2. So the 4 needs to be positive, and the 6 needs to be negative. We'll keep going. We're going to set this equal to 0. Negative 3x to the third equals 0. You can go through the steps, divide both sides by negative 3, x to the third equals 0. But what's going to happen when you take the cube root, what times what times what equals 0? It means x equals 0, and it has a multiplicity of 3. So there's 3 answers. The next one, we just solve this and get negative 4. There's another answer, and we'll solve that for x, and we get positive 6. So we have 1, 2, 3, 4, 5 answers, and that's great because our degree was 5. Good luck studying for the test. Hopefully this helped you, and hopefully you have your review done now.